Objective number 1 says, know what the kinetic molecular theory is and what the 3 assumptions are about gas molecules. And really, this is true about any molecule, but especially gases show these things. So assumption 1 is that the size of the molecule compared to the size of the atoms are really, really small. So really what this is saying, there's lots of space between gas particles. But the bigger thing with size and space is that that space can change.
Ashley Allen, please call 88480. Ashley Allen.
What factors would change the space? What could you do to your gas to make the spacing get bigger or smaller, either one? You could add energy. I can spell here, if you add energy, usually we do that in the form of heat, but it could also be like a fan blowing across it. What else could you do to, how would you reduce it? What's it? Yeah, you could change the pressure. Okay, and the other one, this one you really can't change, but depending upon the intermolecular force, the spacing could change too. Okay, a lot of times we change pressure by changing the size of the container. So I'll put in here or volume. They often change together, but they don't have to both change, but often they do. So then assumption number 2 talks about motion and collisions.
Chocolate chip oatmeal cookies for 126 for the block.
Oh, great. There goes the study session. Okay, motion and collisions. First of all, there's a word called elastic collisions. Anybody remember what that means? Yeah, collisions are elastic, meaning no energy is lost when particles collide. Now that's not true like when you have a ball that you're bouncing against the wall or whatever. We do lose energy in those collisions. So that's unique. The other thing we should know is collisions are what lead to that magic word that everybody likes to use. What 2 things will affect how much pressure is in a container? What would create more pressure in there? What could you change about the collisions to create more pressure? The particles could have more energy, so they hit harder. Or what would be the other thing? Determined by the amount of energy in collisions. What's the other obvious one? I can't quite hear you with these on. So more collisions. Yeah, smaller space would create more collisions. So that's why pressure goes up in a smaller space. So pressure is determined by the amount of energy in the collisions and the number of collisions. So you can see increasing temperature, which one is that going to affect? Which of these 2 factors here? Is it going to have a bigger effect on energy or number? The energy. And actually when you move faster, then you collide more often too. But when you decrease the volume, then you're affecting the number of collisions. So that's why you don't always have to change temperature to create some of these changes. But that's a big idea with motion and collisions. When you have more motion, you have more collisions. And then assumption number 3 is temperature and energy. And what this is really talking about is the fact that more energy or temperature, they go hand in hand, leads to more, well, I should say more motion, so more collisions. And when you have more collisions with more motion, guess what happens to your spacing? Gets bigger, right? When you throw a ball harder against the wall, it bounces further back. So that's what we're going to see as this thing expand. If it can. If it can't expand, then the pressure's going to build up. So kinetic molecular theory is really all about particle motion and whether you're speeding up and spreading out particles or you're slowing them down and pulling them closer together.